Our description of the algorithm has talked about paths in the state space. I want to say a little bit now about how to implement that in terms of a computer algorithm. We talk about paths, but we want to implement that in some ways. And the implementation, we talk about nodes. A node is a data structure, and it has 4 fields. The state field indicates the state at the end of the path. The action was the action it took to get there. The cost is the total cost. And the parent is a pointer to another node. In this case, the node that has state S, and it will have a parent, which points to the node that has state A, and that will have a parent pointer that's null. So we have a linked list of nodes representing the path. We'll use the word path for the abstract idea and the word node for the representation in the computer memory, but otherwise you can think of those two terms as being synonyms because they're in a one-to-one correspondence.
On the top, it shows a path from A to S, then to F. There's a linked list corresponds to this path. Each node in the linked list has 4 member variables. The first variable is state. The second variable is action. The third variable is cost. And the last variable is a pointer to the parent node. Therefore, the parent pointer of node F points to node S. The parent pointer of node S points to node A. The parent pointer of node A is null.
Now there are 2 main data structures that deal with nodes. We have the frontier and we have the explored list. Let's talk about how to implement them. In the frontier, the operations we have to deal with are removing the best item from the frontier and adding in new ones. And that suggests we should implement it as a priority queue, which knows how to keep track of the best items in proper order. But we also need to have an additional operation of a membership test. Is a new item in the frontier? And that suggests representing it as a set, which can be built from a hash table or a tree. And so the most efficient implementations of search actually have both representations. The explored set, on the other hand, is easier. All we have to do there is be able to add new members and check for membership. And so we represent that as a single set, which again can be done with either a hash table or a tree.